Yes, last Thursday, we started our discussion on inferential statistics. So we want to proceed. We talk about, we started discussion by describing what inference is. This is generalization we make from sample to population. And from there, we also discuss the two types of the generalization, inductive inference and deductive inference. We also talk about sampling distribution. And here we see the distribution of sample statistics and of a sample that is drawn repeatedly from a population. We also proceeded to talk about central limit theorem. In central limit theorem, we talk about the statistic of the sampling distribution of certain statistics will tend to normality, especially if the sample size increases, irrespective of the original shape of the variable involved. We talk about standard error as the standard deviation of a sampling distribution, standard deviation, the sampling distribution. And we also talk about this standard error as something that just something that gives you an idea of what population standard deviation is. And that's why some people originally say that standard error is the standard deviation of in the population or population parameter. But the issue there is not true. It's actually the standard deviation of a sample distribution, but it's believed to be equal to the standard deviation in the population because it's like a proxy to measuring the standard deviation in the population. We now say that this standard error will show you two things. One, show you how the attribute vary in the population. If the standard error is small, it means the attributes are very close naturally in the population and the values are very close. We give example of height. Height are very close in the population, closer together than weight. So the standard error of height will be smaller than that of the weight. I would say that this standard deviation, nobody do repeated sampling again. It's just the intelligent people have discovered that if you just measure the standard deviation once, you just divide by the square root of sample size, it will give you the standard error. And the most important attribute of the standard error, apart from the one I've just said that it shows you how the variability is in the population, the most important usefulness is whenever the standard error is very small, it means your estimate, the statistic you have estimated is very parameter. If it's very large, it means that your estimate is likely far away from the parameter. Just like if you say, oh, you just calculate mean hemoglobin concentration, the mean hemoglobin concentration, maybe is 17. You after calculating that, you now calculated the standard error. You now see the standard error is something that maybe you are comparing two groups. You now see that the standard error is very large in one group. So this one that is very large, it means that that attribute, that summary you get for that group is very far from what it will be in the population. That value, particular mean you calculated for that group may be far from the origin. But if you are to know, you actually know, maybe somehow you're able to know the real population parameter, you discover that what you have calculated as your statistic is far from the reality. But if the one that has smaller standard error is to be closer to the value in the population. That's the number one usefulness of standard error. And we talk about something, we said that we are going to be looking at two categories of inferential method, because all this discussion about sampling distribution, standard error, central limit theorem, is just to whet our appetite, is to let us, just to give us a glimpse about inferential statistics. So we have two categories we want to look at. want to look at hypothesis testing. So it's an inferential method, and confidence interval is a separate method. So you need to know the difference, because sometimes we present result, the two will be on the same table. When you see p-value, you see one statistic and p-value. For example, now, if you do logistic regression, you see what statistics and p-value, that is hypothesis testing. When you see odds ratio and the confidence interval, that's confidence interval. You see, there are two different methods. And normally you are not supposed to, if they are the same thing, why are you presenting the same? Presenting them at the same time? It's because we are afraid that if you present one, you don't present the other one. They may ask you. Actually, the one that gives more information, as you're going to see, is the confidence interval. Give more information than the p-value. But the p-value, the hypothesis testing hand is p-value. I think we'll proceed. As we proceed, we're going to get to understand better. What is hypothesis testing? It's a method for decision making. The decision we are talking on here it relates to the choice between two competing mutually exclusive statements regarding one or more population parameters. You know, as a researcher, you are interested in what is happening in the population. Maybe the weight of the people, or the, the prevalence of hypertension, or whatever. You know, what you are interested in may come in form of mean, standard deviation, or come in form of proportion, percentage. It depends on the type of variable you are dealing with. So when you are just saying, okay, hemoglobin concentration, just want to know, in that situation, we are talking of quantitative variable. So you talk about the mean, standard deviation, and we talk about the median, whatever. But when you, the same particular work, you can have a cutoff for the hemoglobin concentration, and now say, okay, you want to know prevalence of anemia. You know that the hemoglobin concentration below certain level is considered anemic. So in that situation, you know the proportion. Who are those? What percentage of the people have hemoglobin concentration below this level? So in that way, you are presenting the same result as percentage. It depends. So most quantitative variable, you can change them by to call it categorical. When you have a cutoff point or you have a range, you range it. Like age is quantitative, but when you begin to have age group from 10 to this, from 20 to 25, or to 13, 21 to 30, or whatever, 20 to 29, 30 to 39, age range, that one is categorical. It's the same thing. When you see hemoglobin concentration below this, that's categorical. You have already categorized it. In that case, you can tell this is the prevalence of anemia. Whichever way you are in, what you are interested in, that thing in the population is a parameter, because it exists in the population, is a parameter. But because you, as a researcher, you don't have access to the whole population, you only have access to the sample pattern. You take your sample, whatever you now do, you will now extrapolate to the population. That is the realm of inferential statistics. And how do you come about it? Is by, okay, for ab initio, from the beginning, you want to, okay, before I do the study, I have an hypothesis. I want to test. So the hypothesis is about relationship between two variables. We want to see, does this relationship exist or it doesn't exist? And for example, we say, okay, we want to see, is there any relationship between a teenage pregnancy and socioeconomic class? That situation now, the outcome measure here is teenage pregnancy. The exposure is socioeconomic class. And here, if you remember when we started discussing under, what do I call it? Under basic concept of statistics and descriptive statistics, we talk about something like, say, population, we talk about sample, we talk about inferential statistics, descriptive statistics, we talk about parameter, we talk about many things. There, we also talk about the type of variable. So a variable can be qualitative, quantitative. That is a simpler classification. I will now say that as time goes on, when we need to classify in another way, we talk about it. Here, it's good to classify variable as dependent or independent, or exposure or outcome. So as a researcher, most of the time, your research question, what you are interested in knowing, is the outcome variable. It depends on something. What you are looking for as a researcher is you want to say, okay, this problem, teenage pregnancy is a problem in the society. What we want to see, what are these things that lead to this teenage pregnancy, so that we cannot solve teenage pregnancy on its own. You cannot say you have children and okay, then lock them up, or what will you do? So you do, they cannot be pregnant, you will not allow your daughter to be pregnant, or how do you solve the problem? Is it by locking them all this, or sewing with their part or whatever? How do you solve it? You look for another variable you can manipulate that determine, that influence that teenage pregnancy. You see, directly you cannot do something about teenage pregnancy, but you can do something about what will lead to teenage pregnancy. So that particular variable, that is the research question, is the problem. Is the problem statement that you cannot do something directly about. But you are now, your research is now looking for, there must be another variable I can do something about. But that variable may be influencing this variable I cannot do something about. Like now, we can do something to improve socioeconomic status of people. So if socioeconomic status determine or maybe influences teenage pregnancy, and our problem is teenage pregnancy, okay, we now say, okay, let's see if we can do something about socioeconomic status. So before you can do that, you must be able to establish that the fact that there is an association, there's a relationship, whatever, there's a link between the two variables. So your outcome variable now is your research question. It depends on another variable that is influencing it. And that your variable you cannot influence is the outcome, is the dependent. It depends on something you can influence. And that one you can influence is the independent variable. So when you look at the relationship between two variables now, one is dependent, one is independent. Though the word dependent and independent was being used by people that were involved in experimental research in those days. While people that were involved in observational research, they prefer using something like exposure and outcome. The research question, one is the outcome, what you're interested in knowing something about. But what are those factors that are causing it? They are the exposure, and they are different exposure, factor, determiner. There are many things, many names you can give. While the other one is the, you can even say the explanatory variable also. Those are the factors. But why the dependent, which is the outcome variable, the same thing as explain variable. So many people call it. So you see that the word outcome actually means, outcome variable means the dependent variable. The word independent is the exposure. Because the people that do experimental research, because they manipulate the environment, they believe that whatever the outcome dimension depends on their own manipulation. And that is why they call the word dependent comes in. Now, the decision you are making now is choice between two competing mutually exclusive statements regarding one or more population parameter. So the population parameter we're talking of is a particular variable, the value of that variable. The competing statement of fact are referred to respectively as the null and alternative hypothesis. So what is null hypothesis? Null hypothesis state that there's no association between these two variables or relationship between the two variables. Teenage pregnancy, socioeconomic status, there's nothing that they don't have anything in common. There's nothing, one does not depend on the other. There's no, you cannot say there's an association. That is, if there is a teenage pregnancy, you cannot say it's because somebody belongs to a particular socioeconomic class. Maybe something else is affecting it, but not socioeconomic class. That is what null says. But alternatives say there is something. So you see here, he's not saying that maybe somebody that low socioeconomic class will more likely have teenage pregnancy. See, there is may mean that low socioeconomic may not likely have teenage pregnancy, or it may likely have teenage pregnancy. It doesn't really matter. But there is an association. It is when you now do that what is the direction of the association or relationship. Some maybe say, what is the difference between association and relationship? Some people say there is no difference. But some people say by the time you association is shallower, while relationship is deeper. Whichever way, we will come with serious many arguments. Just know that when you are looking at either we call relationship or association between two variables, if your statement says there is none, that's not hypothesis. If there is, it's alternative hypothesis, whether you are talking of association or relationship. Now, these hypotheses, they are mutually exclusive. These two, that is, if there is, there won't be, there's no. If you say there's a relationship between teenage pregnancy and socioeconomic factors, if that is true, and then there's no association will not be true. So both the two statements are mutually exclusive. Now, you will now ask, why do you test? Which one do you test? Before I go to the next slide, I just talk about the step in testing this hypothesis. Which one do you test? You test no hypothesis or you test alternative hypothesis? You can be writing your question. You can type your question and shout it. When we finish, we attend to them. Now, if you say there is an association, there are many ways you can have association. If they say there's no association, it can only occur in one way. Now, the one you test is not hypothesis. You don't test alternative hypothesis because alternative hypotheses are plenty. If you say there's a difference between, okay, I use the word different now. You know, we talk about association or different. So if you look at the two statements, mutually exclusive statement we are talking about, there is an association between teenage pregnancy and socioeconomic status. There is no association between teenage pregnancy and socioeconomic status. Those two statements are mutually exclusive, but I will use the word association. But you can as well say there's a difference. But the way you carve it means the same thing. Some people also come with say there's a difference between association and different. But statistically, when you are carving what I'm all about here now, when you are saying it, the way you phrase them, you are saying the same thing in different way, but you have to phrase them differently. Because it's the same thing. If I say there's an association between teenage pregnancy and socioeconomic status, if you look at teenage pregnancy, it's a variable because it's either yes or no. It's there or not. Because we want to elicit the response, we want to collect data. It's either the person is pregnant or not pregnant. Then socioeconomic status. You may have class. You may say, okay, you're having 3 classes or 2 classes. Even if you have 5 classes, whichever class, but one person with a time will belong to a category. You will see that these two variables, there are 2 separate variables, socioeconomic status and teenage pregnancy. Association between 2 variables. But if you want to use the word different, you cannot say there's a difference between teenage pregnancy and socioeconomic status. It doesn't make sense. What does it mean? So when you want to use the word difference now that is where the outcome variable has to come out. There's a difference in the value of the outcome variable between the different categories of the exposure variable. Can you see now? Socioeconomic status, teenage pregnancy, these are 2 variables. But unless you can say there's an association between teenage pregnancy and socioeconomic status. Or you say there's an association between socioeconomic status and teenage pregnancy. It doesn't really matter which one comes first. It doesn't really matter which one comes first. The issue there is there's an association between these 2 variables. But when you want to use the word difference, you must now state the outcome variable. So I want to state, and I will say, let me give an example. There's a difference in the rate of teenage pregnancy between the different socioeconomic status. Can you see? If let's say I have 2 socioeconomic classes, upper and lower, I can say there's a difference in the teenage pregnancy rate between upper and the low socioeconomic, or even among low, middle, and upper classes. The issue there is that the difference I'm looking at is different in the outcome variable. it is different in outcome variable. It's not different in the exposure, but it's the different in outcome variable between different categories of the exposure. Just give me 1 minute. 1 minute. Hello, I'm back. Now, so when you are talking about difference, you are talking about the value of the outcome between the different categories of the exposure. So when they mean the same thing. So some people will just write there's no difference in the socioeconomic status. There's no difference between socioeconomic status and outcome and teenage pregnancy. It doesn't make sense. So that's the only difference, the way you phrase it. So your null hypothesis, you may decide to use association or relationship. When you use association or relation, you just say there's no association or there's no relationship between these two variables. That's all. And if you want to use the word different, there's no difference in the value of the outcome variable, which is the dependent variable, among different categories of the exposure variable. So now, what the fact I wanted to bring up before was that you only test the null hypothesis, you don't test alternative hypothesis, because there are many alternative hypotheses. Like, for example, if you say there's a difference between my age and your age, somebody will now ask you, what difference? There are infinite number of ways your age can be different from mine. It can be 1 day, it can be 2 days, 1 week, 3 year, 1 year, 1.5 year, 1.25 year, 1.2, 1 year, 1. So you can see when there's a difference between two things, there are infinite number of ways those two things can be different. So if you have to test the alternative hypothesis that's a difference between those values, you see that you have infinite number of hypotheses to test. There won't be end. You have to test that the difference is 1, and if it's to find out if either true or false, or the difference is 2 or 1.5 or 1.007, infinite number of the way things can be different. But if you say there's no difference, which is the null hypothesis, there's no difference. If I say there's no difference in my age and your age, you cannot be asking me how much difference. Say there's no difference, it means the same. There's no difference. It's 0. There's no difference. So it's just 1. That is why the null hypothesis is only 1. So that is why you test it. Of course, you know that if the null hypothesis is true, the alternative hypothesis cannot be true. So you cannot, because the alternative hypothesis is difficult to test, because you have to test infinite number of ways the alternative hypothesis will be true. But if it is not hypothesis, you are dealing with only 1. And that's why you test null hypothesis. And if null hypothesis is true, the alternative hypothesis will be false, not be true. Though you don't want to use the word false, as you go to see. Now, the step in hypothesis testing, state the null hypothesis and the alternative hypothesis, which we have already talked about. Choose a significant level of alpha for the test. Obtain the probability of observing the result and the result more simply extreme. If the null hypothesis is true, use p-value to make a decision on whether to reject or not reject null hypothesis. This, you know why I just read through? It looked funny because you see that some of the things we listed there, alpha, what does it mean? So you better understand it when you get to this table here, the next table. Because there are some things, you rather understand the logic behind it that somebody just biting the tongue. It's just like if we talk about, when we talk about sample size determination, if you don't understand inferential study, you will not even understand, because there you see this alpha, you see Z, you see p-value, significant level, they will say something that relates to what we are having here. Level of significant confidence interval, confidence level. If you don't understand the inferential statistics, you cannot even know how to determine sample size. You see? So there was a time we were to conduct this training in one of our institutions when I send my topic, and some of my colleagues that are public health consultants now go back to me and said, hey, well, they look at this. Some of our people made comment about it. We say some of these topics are not statistics, they're epidemiology, the study, and the way you arrange them. So when they talk, and that's okay. You are those people, because I know some of them. They say, well, I say, because those people, they don't know me. They are talking as lecturers. I'm talking as what I put there as facilitator. Or let me say they're talking as, well, is it teacher or lecturer? Because lecturers will give their own topic, even if that topic may be the last one that should be given. Since the lecturer is traveling, he can come and will give us, I want to give my topic now. Forgetting that the way they arrange the topic, they are supposed to have given the other one. So giving his own topic because you want to travel, will even run more havoc. It's better you leave the topic on, and leave it there and travel. But you still go and give it. People will be confused because they need knowledge of the previous one to understand. So sometimes you see that there are some things there, the way they are arranged, for you to understand, facilitate your understanding. It doesn't have to be the way you know it. You may think, well, sample size first now before you collect data, you analyze. No, with that sample size, there's a relationship between, though the sample has to do with the relationship between sample and population, and between descriptive and spatial statistics, between the statistic and parameter. So you discover that the best way to put is the best way for people to understand. It's not necessarily think, it's just like a chicken and a egg, which one comes first. So whichever, the one that people understand first should come first, doesn't really matter. Now, let's quickly, for you to understand this slide, let's come to this slide. Non-hypothesis. Let's look at statistical error here from this table. So the summary of what we have just said was that if you want to know if there's association or relationship between two variables, so what you do, you carry out your research to find out if there's an association between two variables. When you carry out your research and you analyze your data, if there is an association or relationship between these two variables, you now say, okay, there's an association. The null hypothesis that says there's no association, I reject it. Because the null hypothesis says there is no association. That's what you are testing. You have the null hypothesis you are testing. There is no association. And you carry out your research, there's an association. What will you do? You throw away the null that says there's no. You now say, oh, there is an association. But if you find out that in recent, just like what you have predicted with the null hypothesis, there is no association, you say, oh, there's no association. But it looks simple, but the decision is a complex one, because you holding null hypothesis to say you are testing, and you have carried out your research to say, okay, there is association, there is no association. Those are the two, you think those are the two options you have. But in real life, it's not like that, because the null hypothesis you have stated also has its own validity. The null hypothesis in the real life, you know that this is the realm of inferential statistics, because you are trying to know what is in the population, which you don't even know. You are just like you are making effort. Something exists in the population. You have access to a sample. All your hypothesis testing you are doing is on the sample you have. You want to talk about population. So when you state your null hypothesis, so it's either it is true or not. So if you look at this table now, look at the vertical axis, the column, you see that null hypothesis. This is status of null hypothesis. When you state it, is it true? If it is true, there's no difference or there's no association. That's that it is true. You see, there's no difference, there's no association. That is no hypothesis. It can be true in real life, which only God knows that there's no difference. It can be false, even though when you say there's no difference in your statement of null hypothesis, in real life, that may be different in real life. So those are the two options for null hypothesis. You see, true, no difference, or it is false, there is difference. But that one has nothing to do with your own decision. Your own decision is based on the result you have gotten when you carry out your research. You carry out your research, you now come, this is your decision based on statistical tests you carry out. You say no difference. You didn't find any difference. Or you say you find difference. You know, when you say you find no difference, if you say you find different, you say you reject, no hypothesis, because no hypothesis say there's no difference. But you find difference in your study, you say, I reject no hypothesis. If you find no difference or no association between those two variables in your research, you fail to reject. You say, instead of you to say, I accept no hypothesis that say there's no difference, you say you fail to reject. The reason they just use the word. It doesn't, if you say you accept, there's nothing will happen. Nothing will cut somebody's mouth. But the logic behind it was that sometimes if you say you didn't find any difference, it doesn't mean there's no difference that exists between them. It may be that your research is not good enough. For example, if the sample size is very low, the power, we're going to talk about it, you will not be able to detect the difference. If you don't detect the difference, no difference does not mean that I reject, I fail to reject. Sorry, I accept rather. Not that you say I accept, no hypothesis. No. So you just fail to reject. It means that you can do it again and come and reject. Another person, fellow, can do the study and now reject it and find the difference. For the fact that you find no difference does not mean. It's just like if they ask you to come and do something or do one exercise, you say, I can't do it. If I cannot do, nobody can do it. It cannot be done. No. For the fact that you cannot do it does not mean it cannot be done. But if you do it, you are proof that it can be done. You can do it, you are proven that it can be done. You not doing it does not prove that it cannot be done. It may be that you cannot, it's you, another person can come and do it. It's the same thing. So if you find it different, that shows that there's a difference. If you find no difference, it doesn't mean there's no difference. It's because you cannot find that difference. And that's why you stand fail to it. But the issue here is that you have two possible decisions you can take. You can find different and reject, or find no different and fail to reject in your decision after you are doing your test. Whereas the statement you have made before, the no hypothesis, by making that statement, you are still on two possible options. The two possible options is your statement can be true, that there's no difference. It may be false, there's a difference. So when you now marry, so you can see now when you take your decision is not just only two possible. You look like two possibilities, but there are four. So when you intermarry, what's the options of you stating no hypothesis as given two options, and the option implication of your own decision. The decision you're going to make is either one of the two, and the implication of your statement is one of the two also. When you marry the two together, it gives you four options, and these are the places where these options intersect on this table. These four cells. I like the four cells. This. So let's start with this. Which one do we start with now? Yes, let's start with this one that talk about power. Let's start with it. Is a correct option if you look at in a situation where after you are stating the no hypothesis that there's no difference, and in real life, we God knows there's a difference. There's a difference. There's an association between the two variables, and your study find the difference, find the association. You reject when the no hypothesis is false. That is correct. It's a correct option because there's a difference, and your study sees that. So that is the power of the study. Is the ability to find the difference if it exists. The difference exists naturally, only God knows, and your study was able to get it. That is correct. That is the power. Power is the ability to detect the difference if it's there. The second option that is also correct is that if in the real life there's no difference, no hypothesis is true, and your study says there's no difference, I can find any difference, you are correct. So in that situation, you just There's nothing. There's no association between these two variables. There's no association between teenage pregnant and socioeconomic status. There's no association between this new drug and treatment, that is, whether the person gets better or not. So that is, the new drug is not effective. So in that situation, that is what is in the real life, and your study has gotten it. You are correct. You will see that in real life, any of these four possible options will happen. They are mutually exclusive. So if you get this one correct, it cannot be this. It can be any of these four. Now, out of these four options, these two concordants are correct. Concordant in the sense that, look at this first one. No different, no different. Look at this one. Correct. Different, different. There's a different, there's a different. But there are two discordant. It is possible that, number one, there is no difference in real life. There's no association between these two variables, but your study say there's a difference. That's a discordant. In real life, there's no difference, but your study say you find something. It's like when the drug is not doing anything for the disease, it's not improving, but you say it's improving. There are many drugs that come out like that because maybe the people that are pushing the drug, they are spending so much, you have to dot the something. They dot the result. So like a pharmaceutical company can pay you money heavily and they want the result. There must be different, there must be improvement. So that is an error. The other error would be there is a difference, but your study says in this case, there's something there, but you miss it, there's nothing. It's like if the drug actually helped to improve the disease condition, but your study says it doesn't help. So you see, if you compare these two now, this one is like the first one, where there's nothing, you say there's something. It's like commission, error of commission. It's not statistical, that word is not statistical, it's not statistical word, but just for you to, it's a social word. When there's nothing there, you say there's something, it's commission. Then this one, this second one, is omission. The difference is there, but your study says no difference, it's omission. So this first one is called type 1 error. When there's no difference, then your study says there's a difference, which is commission. Type 2 error, when you say there's a difference, there's no difference. When in your study, in actual fact, there's difference. So that's why they say type 1 error is also called alpha error. Type 2, beta error. Type 1 error is rejecting non-hypothesis. Look at it, you reject it. When it is true that there's no difference, but you reject it that that's a difference. Rejecting true, rejecting the truth, rejecting non-hypothesis when it is true. While type 2 error is not rejecting or fail to reject non-hypothesis when it is false. Not rejecting non-hypothesis when it is false. Can you see? So if you remember, just say rejecting the truth, not rejecting the false. You from the statement, you know that they are not proper. You reject the truth, you fail to reject the false. So it means that you have not done the right thing. So now, alpha type 1 error, type 2 error. Sarcastically, they say one king made these two errors. They committed the two errors. They say the king had two servants, and he suspected that one of them was sleeping with the wife, and he now suspected the one that is handsome, swagger, must be the one, because I had the notion that one of them was sleeping with the wife. So he therefore the one that is handsome should be the one sleeping with the wife, and now fire him, and now promoted the other one that is not as handsome, whereas it's the one that he didn't fire that was doing the havoc. So he committed both error. So that is just a sarcastic explanation. Now, I want to start with this beta error. You will see the relationship between beta error and power. Because if you look at it, if you are to tabulate on this table now, you add up and put total undernet. You see that if we are putting them on our table and put over 100%, you will add beta error, type 2 error, and power to make 100. So beta, if your power is, if your error is 20%, your power will be 80%. They are complementary. So if you increase the beta, you will reduce the power. But somehow also, the alpha and beta, if you want to reduce this one, you have the likelihood of increasing the type 1 error. If you try to reduce type 1 error, type 2 error will increase. But the relationship between beta error, which type 2 power, is you add up to 1. You know, when we talk about 100% and 1, we have talked about it in statistics, in a probability. 100 means 1. Just a matter of division by 100 or multiplication by 100. So when I say 100% is 1, 20% means 0.2, 50% is 0.5. So if your power is 0.8, 80%, your beta will be 0.2. So they are complement, they add up to 1. Now, this probability of making type 1 error is what we call p-value. I don't know if I have this thing of me. I just draw something to explain that. The probability of making type 1 error is p-value. I want to share a whiteboard, so you can see the whiteboard now. No, you know that we say the probability is from 0 to 1. One hand here. This is a scale of 1, 0 to 1. Let's say this is probability scale. From beginning 0, 1. Now, the alpha error is the probability of making type 1 error. P-value, the probability of making the alpha error. Another way of saying it, which make it maybe complex, that the probability that the difference you find is due to chance. But if you try to even conceptualize it through that approach, you get confused. People get confused many times. But the best way to conceptualize the probability of you making type 1 error is the p-value. Now, p-value is probability. That's just it. That p you are seeing is p means probability. Now, the end point of every hypothesis testing is this p-value, this probability. It's about this conclusion we talk about. Now, if you say the probability of making type 1 error is p-value, if p-value is 0, what does it mean? It means that I have not made type 1 error, because type 1 error is rejecting not hypothesis when it is true. Saying something is there when it is not there. So if it is 0, it means that I have not said something that is there when it is not there. I have not committed the error. If I say, this is what I found, that should that is there. I have not said I found something that is not there. The probability that I have found something that is not there is 0. Means that whatever I say I found is there. So if I say is 1, what does it mean? It means that probability that I found something that is not there as there is certain that I've committed the error. So it is easy for you to understand this from these two extremes. But in real life, it's not like that. It may not be 0, it may not be 1. Most of the time, it's in between 0 and 1. Okay, at what point are we going to say that somebody has committed type 1 error? Because it's 0, it means 0, you have not committed type 1 error. 1 means you have committed type 1 error. But what if it can be anything? Probability can be anything between 0 and 0.2, 0.3, 0.45, 0. Anything up to before you reach 1. So if it is anywhere there, where is the cutoff? When are we going to say? So that is why some intelligent people are okay. let's say 1 out of 20 times. If you put 1, that is, if I made attempt 20 times and I committed the error 1 time, it is believed that, let's just say that it's too low, I didn't commit the error. 1 over 20 will give you what? 0.05, which is 5%. All over 20 is 5%, 0. So on the scale, so people now say, okay, let's say this is 5% at 0.05, which you can write as 5%. Is an arbitrary value. So it's like a cutoff point that anything that is higher than the, let's say, it's becoming too, that probability is becoming too higher. You want to say that you have committed, the probability is too high. But if it is lower than this, from down to 0 side, it's very low. So the p-value is like a score in the exam. No score in the exam is on 0 to 100% also. But the cutoff will now be, the cutoff now was what significant level. At what level are we going to say, okay, the difference I've observed is significant. I cannot say that I've committed error. That is the 0.05 arbitrary value being chosen. So can you see the difference between p-value and significant level? P-value is the probability that you have committed type 1 error. Then the value of probability as low as maybe no more than 5%, 0.05. It is that 0.0 is 0.05 is the significant level. That's the level I want to reject null hypothesis. The level at which you now reject null hypothesis and I say, wow, I've rejected null hypothesis. That is the cutoff point. P-value of 0.05. Now you can make it more strict. Some people choose p-value 0.001 or 0.01 rather, which is 1%. You know that 1% is more strict. Somebody that rejected at 1% is more strict than the one person that rejected at 5%. So you can use anything, but people don't use anything. If you use 4%, there's nothing bad. 3%, but people don't just use it. But if you use anything more than 5%, people believe that it's becoming too much. And that is just interpretation. So if you understand this, that the probability of making type 1 error is a p-value, which is actually the probability that the difference you have gotten is due to chance occurrence. That is, when you do your studies, look, the teenage pregnancy among the low socioeconomic class is 50%, is 20%. Among the high socioeconomic class is 10%. You can see the difference of 10% between them. This difference, is this chance occurrence? If it is chance occurrence, if the probability that is due to chance occurrence, if it's bigger than, it's close to that one, that is, it is certain that it's chance occurrence. It's not a difference. It's just what we just saw now is a chance. If I redo it again, you may even see that the teenage pregnancy may be more among the high socioeconomic class. So this difference we are seeing just by chance. It just happened like that. It's not as if there's any difference. That's what that probability means. As it's becoming bigger, it means the probability that is due to chance occurrence is close to 30. It's a chance. So this result that I'm seeing this difference. This difference is not real. Can you see? But if the probability is very low, lower than 0.05, this difference I'm seeing, the probability that is due to chance is so low, so small. This is not due to chance. Actually, it's like the people of low social or economic class are more likely to have teenage pregnancy than this other people. That is the summary of that. And if you come back now, you'll be able to understand, okay, you state your null hypothesis, an alternative hypothesis, choose a significant level. That p-value, this level of significance. So when you want to do your study, you must first of all make up your mind. Which level am I choosing? Am I choosing 5%? Am I choosing 1%? You have to first of all make up your mind at what level you're going to choose. Then obtain the probability of observing the result. the obtaining the probability is calculating the p-value, and then use the p-value to make decision about whether to reject or not reject. You see, that is why I said that this thing you have here, this step here, unless you are able to look at the table and conceptualize, you may not be able to grasp it. And that is all. P-value at significant level, I've already said it. The p-value is the probability of rejecting no hypothesis when it's true, or the probability that the difference you find is due to chance. At what level do you reject? You say, no, this one is not due to chance, or this one is due to chance. That is significant level, and which is usually set at 0.05 or 0.01. But I think we stop here, because the next one we now look at confidence interval. We have just discussed hypothesis testing. Now, that is how test you do, whether t-test, chi-square, ANOVA, think of all statistical tests, they end with p-value. So when we finish discussion on hypothesis testing, and now to finish discussion on confidence interval, we now look at hypothesis tests. What are those tests? Those tests that end in p-value. Those are the things where we'll be thinking of chi-square, Fisher-Exact, t-test. Think of any test you may think of. You see regression you are doing. You think of anything you talk about. ANOVA, think of all the tests, either parametric or not parametric. That's why we'll be discussing them. Because the type of test you now, even though it ends in p-value, the type of test you do depends on the type of variable you are dealing with. The study design, the number of group you have. So the type of variable and the study design will determine the type of hypothesis test. But the end point of hypothesis test is p-value, but which is quite different from confidence interval. I think we stop here. Let's entertain question. Yes, I saw 4 charts. Yeah, thank you very much, sir. So where does the alpha level come in? Yeah, I think this person sent this chart before I explained that alpha level, because the alpha level is the what we got the significant level is the alpha level. So they just use it. The type of error related to it is the alpha error, type 2 error, the p type 1 error rather, which is the probability of making type 1 error is the p-value. But the level of significance, they call it alpha also. Call it alpha level. Maybe that's why the question the person is asking. Okay, is the significant level? Yes, I think the person has grasped it. This can there be experimental study that stated with alternative hypothesis? Yes. You know, when you state hypothesis, you state the two. But there's no hypothesis without alternative hypothesis. When you state no hypothesis beside it, you state the alternative hypothesis. It's only that you test the no hypothesis, you don't test the alternative hypothesis. I think it's supposed to be 4 charts. Okay, maybe it's still remaining 1. Oh, I didn't see. I saw 4. Okay.
Sorry, sir. Okay, maybe I didn't ask that question very well. I was trying to ask that is it possible that the experimental studies, I don't know, I'm just saying hypothetically now, that started with, or that tested alternative, because I'm just thinking, if they're experimenting a drug, for example, that they know, this drug already treats this particular ailment, it's already in existence, but they're trying to see the degree. Let's say, does it improve, for example, high blood pressure by 20 millimeter mercury? So we already know that it works. So it's what they're now looking at those different. You talked about how, with alternative, there are various different, because it's usually better to start with no, because with the alternative, there are various points in terms of
you say the two together, you only test the no. You see, this question you are raising now, even if the drug has been working, you want to know if it improved by the blood pressure by 20. That one itself is another research question. So you can say it does, it doesn't. It doesn't is the null hypothesis. It does is the alternative hypothesis. And statistically, when you are testing, it doesn't you will test. If the null you will test, of course. Whatever happened to the null give you because the alternative is just like male or female. They say the person there is a male, say it's not a male, and it must be a female. If they say it's not a female, then it must be male. So it doesn't really matter. It's just like somebody, they say that reception, you let the lady be receptionist because they are more likely to receive people, put the lady forward because they are more, they have a way of, receiving people warmly. But either you put the lady there, if they say, is a lady there? You say yes. That shows that it's a lady. If they say it's not a female, that shows that the person is a man. So it doesn't really matter. The null hypothesis is the one that is being tested. But if it is true, that shows that the hypothesis in the alternative cannot be true. If it is false, if it's not true, that shows that the alternative is the truth. You get it now? So even when you say something increased by 2, so notice what I was asking when you say something alternative, when you say 2 things are done the same, they are different way. Like what you say now, this drug improve, it can improve by 20, it can improve by 10. But if you pin, does it improve by 20? Yes or no? So it improved by 20 is the alternative. It doesn't improve by 20 is the null. Does it make sense now? So the question somebody was asking here is which error is more expensive? I think I've said it. The error, type 1 error is more expensive. It's error of commission. It's more expensive than omission. And that is why in the law court, even in medicine, even as doctor, if you make mistake, you don't know how to treat, you make mistake, it's different from you committed, you put the wrong thing. If you don't even treat the person, it's better than you admitting the wrong thing to people. Though in medicine, they usually weigh the 2 types of error, depending on the type of the disease you are dealing with. They talk about cancer, alpha ketonuria. They say that alpha ketonuria is something that's a metabolic problem that if you detect it, you can solve the problem somehow. So you are not permitted to miss it. You should miss it. If you miss it, it's a grievous error. In that case, error of omission is more grievous for alpha ketonuria. But for cancer and HIV, error of commission is more. If you cannot, there's no treatment for a particular cancer, there's no point diagnosing it. Because if you don't diagnose it, the person can still even live, even with the thing kill the person. But if you diagnose it, the person will even die faster, knowing that this thing will kill this man, you are diagnosed, but I cannot help you. So that type of thing is better you don't even diagnose. You just leave it rather than committing and say, yes, you have this. So in law court, you will notice that it is better for somebody. That's why they say when it comes to some offenses, they say that beyond reasonable doubt, even if you know that this person, you have all the evidence that this person committed this murder, and there's one doubt that it's not. It's better leave that person. It's better leave that person because it is better you allow offender to go scot-free than to now execute a person that is innocent. Imagine they sentenced somebody to death and he did not commit the offense. That error is more grievous. That's the person that committed the offense that is set free. So it's better you set somebody that committed offense than committing or indicting somebody and not sentencing somebody that did not commit offense. So in the law court now, error of omission, error of commission is more grievous. And even in statistics, it's more grievous. In every way, it's more grievous than the error of omission. Okay. Type of error. Okay, somebody talk about false positive. Yes, this issue of false positive you are talking of, it just you go back to that table now. If you go back to the table, it's the same. Well, the same table they just use in different way. You know, if when we get to what false positive come in readily when we talk about diagnostic text. Now you can look at this now. Different, no different. This is true. Different. No hypothesis. This is the no hypothesis is true. The no hypothesis is false. Then here you now say okay, false positive. This is if this one now, if you are looking at not hypothesis, because what you have here is not hypothesis, it is true. And here, no different, it is true. This is like true positive. But this is false. Can you see now? Okay, from here, no, from here you may, okay, this one say false, this will be the false positive, because this one say no hypothesis is saying that it's true. False positive, false negative. But I will not advise you to even use it to avoid use the word false positive, false negative here. Just understand the way it is. Type 1 correct decision, type 1 type 2 error. The word false positive, false negative, leave it to diagnosis text. When we get to diagnosis text, that one is very straightforward, because there you see the disease is there, it's not there. Then your test, is it positive or negative? Because the test that comes are positive and negative. The disease is true or false, there or not there. So that's where the false positive, though you can apply it better, leave the word out so that it doesn't confuse you. Now, somebody is still sending, thank you. Okay, I think we are through. Any other question? So if there's no question, this is 30 minutes after.
Hello, sir.
Yeah, go on. Go on. Somebody is asking a question. Go on.
Yes, thank you very much, sir, for the explanation so far. Please, I want to the area of that the trying to explain the issue of chance. That is when you talked about the null as being when you gave the example as from 0 to 1. And you said that the level of significance is 0.05, assuming that is our level of significance. That if it now occurs that your calculated value is less than 0.05, I just want that interpretation.
If your calculated value is less than 0.05, because you have chosen that 0.05 as your level of significance, that is the level you say that if your value is more than that, that shows that the probability that what you are doing is due to what the difference you have seen is due to chance. It's not a true difference, due to chance occurrence. It's very high. Once it's greater than 0.05. That's why as the p-value is great towards 1, greater than 0.05 towards 1, is less significant. Because it is believed that the probability that I've made type 1 error is very high, or the probability that the difference I'm seeing with my high is due to chance is very high. So you now reject that there's no difference. But if the value, calculated value is less than 0.05, very small, it means that the probability that I've committed type 1 error is very small. Or the probability that what the difference I'm seeing is due to chance.